Welcome to SS2 Further Mathematics, Term 3, Week 13. The normal distribution is the most important probability distribution in statistics. It describes the distribution of many natural phenomena, heights, weights, exam scores, measurement errors, and forms the basis of statistical inference. By the end of this lesson, you will define the normal distribution and state its properties, calculate probabilities using the standard normal distribution and z-scores, use normal distribution tables, and solve WAEC further mathematics problems. Let us begin. The normal distribution, also called the Gaussian distribution or bell curve, is a continuous probability distribution characterized by its bell-shaped, symmetric curve. It is completely described by two parameters, mean mu, and standard deviation sigma. Probability density function, f(x) equals 1/ sigma square root 2 pi times e caret dash x mu superscript 2 sigma superscript 2. Properties of the normal distribution, symmetric about the mean mu. The distribution has a single peak at x equals mu, mean equals median equals mode equals mu, all equal because of symmetry. The total area under the curve equals 1, it is a probability distribution. The curve extends from -infinity to +infinity but is negligible far from the mean. The 68-95-99.7 rule, empirical rule, approximately 68% of values lie within one standard deviation of the mean, within mu plus or minus sigma. Approximately 95% of values lie within two standard deviations, within mu plus or minus 2 sigma. Approximately 99.7% of values lie within three standard deviations, within mu plus or minus 3 sigma. Notation: xn mu sigma superscript 2 means x follows a normal distribution with mean mu and variance sigma superscript 2. Example: if heights of SS2 students are normally distributed with mean 165 cm and standard deviation 8 cm, then xn 165, 64. About 68% of students have heights between 157 cm and 173 cm, 165 plus or minus 8. About 95% are between 149 cm and 181 cm, 165 plus or minus 16. The standard normal distribution has mean mu equals 0 and standard deviation sigma equals 1, zn 0, 1. Any normal distribution can be converted to the standard normal using the z-score, standardization z equals x, mu, / sigma. The z-score measures how many standard deviations x is above, z greater than 0, or below, z less than 0, the mean. Probabilities are found by looking up z-values in the standard normal table, z-table. The table gives p, z less than or equal to z equals phi e z, the cumulative probability from -infinity to z, key values, phi or 0 equals 0.5, probability of z less than or equal to 0 is 0.5, the mean splits the distribution in half. Phi 1 is almost equal to 0.8413, 68.3% of distribution is below z equals 1. Phi 2 is almost equal to 0.9772. Phi 3 is almost equal to 0.9987. Symmetry: phi z equals 1, phi z, the curve is symmetric, so area below z equals area above z. Worked example 1, xn or 50, 25. Find p, x less than or equal to 55. Z equals open parenthesis 55 minus 50 close parenthesis divided by 5 is equal to 1. P, x less than or equal to 55 equals p, z less than or equal to 1 equals phi, 1 equals 0.8413. Worked example 2p, 45 less than or equal to x less than or equal to 58. Z1 equals open parenthesis 45 minus 50 close parenthesis divided by 5 is equal to -1. Z2 equals open parenthesis 58 minus 50 close parenthesis divided by 5 is equal to 1.6. P, 45 less than or equal to x less than or equal to 58 equals phi or 1.6, phi minus 1 equals phi or 1.6, 1, phi 1. Phi 1.6 is almost equal to 0.9452, phi or 1 equals 0.8413, 1 minus 0.8413 is equal to 0.1587. P equals 0.9452, 0.1587 is equal to 0.7865. Worked example 3p, x greater than 62. Z equals open parenthesis 62 minus 50 close parenthesis divided by 5 is equal to 2.4. P x greater than 62 equals 1, phi 2.4 equals 1 minus 0.9918 is equal to 0.0082. About 0.82% of values exceed 62, quite rare. Sometimes we know the probability and need to find the corresponding x value. This is the inverse normal problem. Method: from the probability, find the z-value, or using the z-table in reverse, convert z to x using x equals mu plus z sigma. Worked example 4, height xn, 165, 64. What height corresponds to the top 10% of students? P x greater than x equals 0.10, P is x less than or equal to x equals 0.90. Find z such that phi z equals 0.90. From z-table, z is almost equal to 1.282. X equals mu plus z sigma equals 165 plus 1.282 times 8 is equal to 165 plus 10.26 is equal to 175.26 centimeter. About 10% of students are taller than 175.3 centimeters. Worked example 5. For the same distribution, find the symmetric interval containing 95% of heights. We need P, z less than or equal to z less than or equal to z equals 0.95. By symmetry P, z less than or equal to z equals 0.975, z is almost equal to 1.960. Lower, 165 minus 1.960 times 8 is equal to 165, 15.68 is equal to 149.3 centimeter upper. 165 plus 1.960 times 8 is equal to 165 plus 15.68 is equal to 180.7 centimeter. 95% of students have heights between 149.3 and 180.7 centimeters. Normal approximation to the binomial, if x bin, n, p, and both np and n1p are large, greater than or equal to 5, then xn, np, np, 1p, approximately. Continuity correction: since the binomial is discrete and the normal is continuous, use p, x equals k, is almost equal to p, k, 0.5 less than or equal to y less than or equal to k plus 0.5, where y is the approximating normal. P, x less than or equal to k, is almost equal to p, y less than or equal to k plus 0.5. P x greater than or equal to k is almost equal to p y greater than or equal to k 0.5. P x less than k is almost equal to p y less than k 0.5. P x greater than k is almost equal to p y greater than k plus 0.5. WAEC Further Mathematics questions on normal distribution. Calculate probabilities by standardizing to z-scores and using tables. Find x from a given probability, inverse normal. Apply the 68-95-99.7 rule. Normal approximation to binomial. Worked example 6, WAEC style: the masses of oranges from a farm are normally distributed with mean 150 g and standard deviation 20 g. A. Find the probability that a randomly chosen orange has mass between 130 g and 180 g. B. 5,000 oranges are packed. How many are expected to have mass more than 190 g? Solution: AZ1 equals open parenthesis 130 minus 150 close parenthesis divided by 20 is equal to -1. Z2 equals open parenthesis 180 minus 150 close parenthesis divided by 20 is equal to 1.5. P -1 less than or equal to z less than or equal to 1.5 equals phi or 1.5 phi -1 equals 0.9332 1 to 0.8413 equals 0.9332, 0.1587 is equal to 0.7745. About 77.5% of oranges. Solution: BECE equals open parenthesis 190 minus 150 close parenthesis divided by 20 is equal to 2. P z greater than 2 equals 1. Phi 2 equals 1 minus 0.9772 is equal to 0.0228. Expected number is equal to 5000 times 0.0228 equals 114 oranges. Examination strategy: always sketch a rough diagram showing the area you want. Use symmetry. Phi z equals 1. Phi z to convert negative z to table-readable form. Be precise in reading z tables. Interpolate if needed. State final answers as probabilities, between 0 and 1, or percentages. Key points: normal distribution xn, mu, sigma superscript 2 bell-shaped, symmetric, mean equals mode equals median equals mu, 68-95-99.7 rule, 68% within plus or minus sigma, 95% within plus or minus 2 sigma, 99.7% within plus or minus 3 sigma. Standardization: z equals x, mu, slash sigma converts to standard normal z n, 0, 1. P x less than or equal to x equals phi z from z table. Useful identities: phi z equals 1, phi z, p a less than or equal to x less than or equal to b equals phi z underscore b, phi z underscore a. Inverse normal: given probability, find z from table x equals mu plus z sigma. Normal approximation to binomial: when np and n, 1p, both greater than or equal to 5, use continuity correction, plus or minus 0.5. Key z values: z equals 1.6455 equals 0.95, z equals 1.9605 equals 0.975, z equals 2.3265 equals 0.99, z equals 2.5765 equals 0.995. WAEC test: standardize and find probability. Find z from probability and convert to x. Normal approximation to binomial. Expected frequency equals n times probability.